All right, we're going to learn about the Duncan index of dissimilarity. And this is basically just a way to measure how segregated or integrated some place is, like occupations, but you can also use it for other things, but we're going to use it for occupations. Okay, so we just use the capital D. The 100, we don't need to worry about. The 100 is just to make it look nice at the end, to make it not be a decimal. And then so we got I equals 1 to n. So, and we're doing a summation, which just means we're going to add a bunch of things up. So n is the number of occupations in our data set. Okay, that's like our occupational categories, maybe you could say. Okay, that's what n means. So if we had, like, 100 different occupations, then n would be 100, and so you're going to have 100 of these little sets of adding two things, adding something together. Okay, so let's see what we're going to add together. We have absolute value. I'll tell you why we have that in just a second. Okay, so we have two groups, x and y are the two different groups, and so xi over x, what does that mean? So xi is just the number. So let's suppose I equals 1 is blue collar. Actually, that's going to be the case in this example in a second. Then this xi is just the number of workers in group X who are in a blue collar job. Okay, and then we divide it by the total number of workers in that group. So we're getting the proportion of workers in that group who are doing that job. And then for yi is the number of workers in group Y who are doing that job over the total number of workers in group Y. So both of these are proportions. So what proportion of it? So let's suppose that, like, one of them is 10 over 100, and then the other one is 5 over 50, right? So then they're both 10% or 0.1. They're both 10% or 0.1. And so the difference between this would be 0. So we're looking at, are they equal in terms of the proportion of their group that is working in that job? So if it's about 10%, if it's 10% of one group, then we would expect, if it's totally equal, we expect the other group to also be equally likely to work in that same job. So that's a general idea, and the absolute value is there to keep the positives and negatives from canceling each other out, because you're going to have some time when one group is bigger in an occupation, and you're going to have other times when the other group is bigger in the occupation, and if we don't put an absolute value, those will just cancel each other out. The dividing by 2 is because there's sort of a situation going on with double counting. We have it's sort of, if you're higher on one side, you have to be lower somewhere else to balance it out. And so if we add up all those differences, we end up double the interpretation that we really want at the end. Okay, so that's why we have that. Okay, so we have two groups and two jobs, a very simple example. So we can think of this as I equals 1 and this is I equals 2, and we can make this group X and this group Y. It doesn't matter which group we make which. We could make the reverse. It doesn't matter. It doesn't matter the order we do it. But we have to have two groups, and generally you'd want these to be the only two groups you're like in your population, right? So sometimes you have to put different groups together in this type of index. And that can be a little problematic for some other reasons. But anyways, so the idea is we have these two groups and want to see, and we have their distribution of where they are working, and it's super simple, just to keep it simple. And we want to see how is this, how segregated is this? Now we could eyeball it, and in this simple case where we just have two categories, eyeballing will work quite well. Eyeballing starts to fall apart when you get more categories. So if you have, like, for example, 500 occupations, eyeballing is a really bad way to decide how equal the distribution is. So typically these indexes are for when we have lots of occupations. I'm showing you with a simple example just because I want it to be very clear what's going on. But then if you do a bigger one, you can use Excel or you can use some other kind of program to help you to do the calculations. Okay, so anyways, gotta put my absolute, oops. I gotta put my absolute value. Okay, so the first one then, this is the white group is X and I is blue collar. So this is going to be the number of white workers who are doing blue collar jobs over the total number of white workers minus the number of black workers doing blue collar jobs minus over the total number of black workers. Notice the numbers are totally made up. They don't really mean anything. They're just something for us to calculate. Okay, then we got the number of professional workers over the total number of white workers who are working as professionals over the total number of white workers, and then we have minus the number of black workers who are working as professionals over the total number of black workers. So notice these two groups are not the same size. They don't have to be the same size to do this. Okay. In fact, generally they won't be the same size. Okay. So we get this, and for most people, the easiest way to finish this is to turn them into decimals. At least for me, that will be easier. Also, you can put the divided by 2 outside if you want. That's fine. So 0.5 minus 0.8. Oh, sorry, I need to put the absolute value. Plus 0.5 minus, oops, that's it, minus 0.2. Okay. And then we can divide that by 2. Okay, and so we're going to get to the end now. So we're going to get 100, and then inside you're going to have 0.3 and 0.3, so 0.6, and divide by 2, so it's going to be 0.3. Okay, so we end up getting 30, right? So that is our Duncan index. The 30 is the Duncan index. So now we need to interpret this, okay? So we need to interpret this, and how do we interpret it? Okay, so let me go talk through an interpretation real quick, and then we'll come back to the, we'll talk through the interpretation real quick. So what this means is, basically this tells us the percentage of workers from one group that would have to change jobs in order to make this distribution equal, okay? So basically that's what it tells us. So it tells us that 30% of black workers or 30% of white workers would have to change jobs in order to make the distributions equal. Now, it doesn't tell us they should change jobs. It's not prescriptive, it's just descriptive. It tells you how far away from this perfect equality in terms of the distribution you are. It also isn't telling you necessarily that being perfectly equal in the distribution is a good thing or a bad thing, okay? So just to make sure that's clear. Okay, so what that means is for 30% of black workers could move to become professionals. So 30% of 20 is six workers. So you'd have 10 left, and then you'd have 6 go here. So this becomes 10, right? This would be plus 6 going here. Okay, or so that's one way, and so now we can see they're equal. They're both 50-50, right? We have 10 out of 20 and 10 out of 20. They're both 50-50 for both groups. 50% of them are working in that group. Or 30% of white workers would have to change from professional to blue collar. Okay, so that would be we're going 30 people here plus 30. So you'd have 50 left. Sorry, 20 left. And then this one would become 80. Okay, and the distributions would be the same. So that's what they mean. Again, it's not telling you to do that. It's not. It's just telling you how far away from this equality we are. Okay, so from our example, we had the 30, right? And that tells us exactly what I just said. And then Duncan index ranges from 0 to 100. Okay, so 0 would be every occupation has exactly the same proportion of the two groups. So if one group is 3% in that occupation, the other group would be 3% of that occupation. Okay, it doesn't mean they have the same number of people in every occupation, because they may not have the same number of workers but if the two groups are totally different sizes. And then 100 would be they never work together. So every job is only one side or only the other, right? So the closer you get to 100, the more you have this extreme segregation, and the closer you get to 0, the less segregation you're finding. And again, it's like a proportional representation that we're measuring here. Okay, so the percent in each occupation identical to their percent in the national workforce. That's another way to think about it. It works with two groups. So when we have more than 2 large racial groups, it can be a little problematic because you have to sort of lump all the other groups together. So if you're looking at like the Hispanic, the Duncan index for Hispanics, you're looking at Hispanics versus everybody else. Or for any group, you're looking at that group versus everybody else. That can be a little problematic, especially if the dividing lines, let's suppose there's like 2 racial groups where their occupations are pretty similar, but they're very different than the other groups. It can be a little problematic depending on how we divide them up. The number can change. So anyways, let's go to one more example. So let's just make this X and Y, okay? But now we don't have, we already get the percentages here, so we can just use them directly. So this is basically just this already, right? Well, times by 100%. But we're basically being given this part, so we don't have to do all that part. We can just use them directly, and this is going to be much easier. Okay, so we can just use them directly. In fact, we don't even have to times by 100 because they're already times 100. They're already times 100. The only thing we have to remember is to divide by 2 at the end. Okay, so we can just do this directly. So for each term, this is 1, 2, and 3. So for this one, it's going to be 10% minus 20%, and then plus 50% minus 10%. So there's a big difference in manufacturing, and then plus 40% minus 70%. And then divide by 2. Sorry if my divide by 2 got a little bit, sorry, a little bit off at the side. Okay, and so then and all these are absolute value, so we end up getting 10% is the difference here because it'd be negative, and then we get 40%, and then we get 30%. And again, absolute value just gets rid of all those negatives, and then we divide by 2, and so we end up getting 80%, which divided by 2 becomes 40%. Typically, we don't write the percent; we just write it as 40. For this Duncan index. So in this case, our Duncan index is 40, and that tells us that 40% of one group would have to change jobs in order to equalize the distribution. And we can see it right here. But for manufacturing, if 10% went here and 30% went here, percentage points, then we would be left with 10%, 20%, and 70%, and it's going to be the same as the distribution for women. Okay, so that shows us how far away we are from being equal, and then we could do the same thing for women moving from service jobs to manufacturing, and then we would end up in the same position. So okay, so anyways, that's the Duncan index. So I hope it's clear. Let me know if you have any questions. I'll be happy to go over it.